Hello, in this OpenGL programming video, we are going to be looking at drawing a triangle. So this is the first video in this series beyond any setup video that we're actually going to be doing some really cool OpenGL. First thing I want to mention is actually there's three things I want to mention. One, I am doing this on a Mac OS X, but once you've got it set up on Windows or even something else like Linux for that matter, the coding will be the same because in this video I'm just tackling OpenGL, nothing platform specific, nothing framework specific. So if you're on Xcode on a Mac, you'll look very similar to what I'm doing. If you're not, if you're on Windows and Visual Studio, then the code will still be the same. I thought I just mentioned that because I know a few people do have a few questions regarding that. The code is still valid. So there won't be a version on Windows because this isn't a Mac version, it's just a version of OpenGL or Triangle that I'm doing on a Mac. The other thing, though this particular one, this tutorial uses GLFW, I'm not doing any GLFW specific code, so this is relevant for SFML, for SDL, or anything else that you're using as well. Okay, so we've got that out of the way. First of all, to start creating our shape in the new modern OpenGL, we need to create some shaders. So above the int main, we know what I'm going to do first. You just zoom in, so it's just easier for you to see. The easier it is for you to see, the better it is overall. So let me just move this over a bit. Ooh, went down a little bit too much, a bit more. Ooh, I want it to go down slightly more. There we go. Okay, so I'm going to put const GL char asterisk. We're going to call this Vertex shader source equal to, this is going to be a string, and this is going to be hash version 330 core. So this is the core shader language for version 3.3 on OpenGL, and this is the one that corresponds to that one as well. But one thing I just want to mention, let's say if you're using OpenGL 4.0, the shader language, the shader version won't necessarily be like 440, it'll be different. So if you Google it, you can get an idea of which shader language you should, which shader version you should be using. Next, what you want to do is put /n, because this just indicates a new line. Because to do the next line in the shader, we're going to click enter, quotation marks. This isn't the most elegant solution, but for this video, this is the way we're going to be doing it. In the next video, we're going to be looking at shader files and abstracting out the two shader files. So just bear with me, but in the next video, we'll be abstracting it out, and we'll have a shader class as well to handle all of that shader goodness. So next thing we're going to do is layout, location equals 0. Yeah, another thing I forgot to mention, this Vertex shader source is just going to be handling the location and positioning. We're going to be having another shader source as well, which is fragment shader source, and that's going to be handling color and textures eventually in this series. So location equals 0 in vec3, which is vector 3. I'm going to call this position, semicolon, \n as usual. Now we're going to put void main. Looks very much like a C++ or a C program, \n. And I'm going to do open curly braces, \n is required on all the lines. You can omit it on the last one, but on every other one you need it there. Now we're going to put GL underscore position. One bad thing about, I would say, shaders in general is because if you're coding it in, I don't know, in Xcode, Visual Studio, Sublime, or anything like that, you don't have IntelliSense, so that adds a layer of difficulty, complexity to coding it. But it's all great fun and it's all good for learning. Equal to vec4, so this is a vector 4. It's going to consist of a X position. It's going to consist of a Y position a Z position and a value of 1.0. We'll be explaining this in a later video. Certain things won't be explained in this particular video. Just stay tuned and it will be explained. And another thing, in the description, there are links to open.gl and learn.opengl.com, which are the websites these tutorials are based on. So I recommend checking them out because they're in written form. They do explain the code a lot more and in more depth than I can do in a video within a reasonable length of time. So I recommend checking out the video, check out that, and you'll learn a lot by doing both. So that's all good stuff. \n, and now it's going to end this line by closing the curly braces, and we're done. Semicolon. Now we're going to create a const gl char. I'm going to call this, should be an asterisk pointer, fragment shader source equal to hash version. You always have to put the version. So hash version 330 core /n, and now I'm going to put out vec4 color semicolon \n. The next line we're going to put void main \n. Now we're going to open curly braces \n. In here we're going to assign color the value of vec4 1.0f, 0.5f, 0.2f, and 1.0f, and we're going to put semicolon \n and just close it off by putting close curly braces and a semicolon. So one thing, let's just talk about this yeah, that's fine. So let's talk about this vec4 here. It has a red, a green, blue, and an alpha value. This ranges between 0 to 1, 0 being off, 1 being fully on. Very similar to color values ranging between 0 and 255. At the moment, we are explicitly setting the color value within our shader, whether that's in a variable like this or in a separate file, but we will eventually get on to passing properties into our shader so we can be more dynamic. So yeah, once we've done that, at the moment this doesn't do anything. We need to actually start loading the shader, compiling it, and checking for errors and actually drawing it to the screen. So what we're going to do is scroll down. We just want to go to after we've done the GL viewport, but before the while loop, we're going to build and compile our shader program. So we're going to put GL uint vertex shader equal GL create shader GL underscore vertex shader. And so at the moment we are just creating a vertex shader. Now we're going to do GL shader source, and for the shader source we pass in this variable that we just created, pass in the number 1, a reference to the vertex shader source, and for the final parameter just pass in no for now. Now we are going to compile the shader using GL compile shader, and we just pass in vertex shader. Now we're going to check for any compilation errors by doing GL int success GL char. I'm going to put this as info log. It's going to be an array of 512 items. And now we're going to get the shader. So GL get shader 4. I'm going to pass in the vertex shader. pass in the compile status, so GL underscore compile status, that is what we want, and then pass in the success, pass a reference I should say to this success so we know if it has done or not. So we're going to check if it's successfully compiled by doing if not success. So if it hasn't successfully compiled, we're going to get the shader log and we are going to, well, let the user know what has happened, or the developer I should say. But GL get shader info log Vertex shader 512 null and info log. Now we're just going to do std cout error colon colon shader colon colon vertex colon colon compilation failed basically, and we're going to put a \n. We are also going to log out the info log so we can see it in more depth. I'm going to put std end line. So scroll down a bit. Now what we're going to do is set up the fragment shader. So we're going to do this is moaning about something. Oh, should be an uppercase L, and yep, that'll fix that. We're going to put gl u int. We're going to put fragment shader. We're going to do a very similar process to what we just did before. Equal to gl create shader gl underscore fragment shader. We're going to set the shader source, so gl shader source, pass in this integer that we just created, so fragment shader, comma 1, comma, pass in a reference to the fragment shader source. Let's put null for now here. And now we're going to compile it. So gl compile shader, pass in the fragment shader to compile, fragment shader. Now we're going to check for any compilation errors by doing gl get shader for fragment shader. So this is what we want to check for. We want to check if it's successfully compiled, or the compilation status, and we're going to assign the value to success. So as you can see, we're reusing success and we will be reusing info log. So what you want to do now is do if not success. So if it hasn't successfully compiled, we are going to get the shader info log. So gl get shader info log, passing the fragment shader that we're checking, passing 512 because that's the size of our info array, passing null, and then the info log array. So it will store any logs into that. We're going to do std cout. And you know what, I'm going to copy and paste this. Did not want to do that. Go down ever so slightly. Here we go. So just want to copy and paste it here. And what I'm going to do is change vertex to fragment, because we're not checking the vertex shader anymore, we're checking the fragment shader. And beyond that, we can just leave it as it is. So next, we are going to be linking the shaders. So we're going to put glu int shader program equal gl create program gl attach shader, And in here, we're going to be passing in the shader program, which is this variable that we've created right here. And we're going to pass the shaders that we're attaching to it. So the first one is Vertex shader. Then we're going to do GL attach shader again. We are going to attach the fragment shader to shader program. We're going to do GL link program. And we're going to be linking the shader program that we just created right now. The next thing we're going to do is check for any linking errors. There's always checking. It's good that you do check for any errors. GL get program IV. I'm going to put shader program. So this is what we're checking for if there's any errors. We're going to be checking the link status, and we're going to be assigning any result to success. Next, we're going to be checking is the linking successful. If not, we will do essentially the same. So what we're going to do, I am going to copy and paste this. I'll copy and paste this line. The other line is slightly different. So let me just go into here, put GL get program info log. We pass in shader program because that's what we're checking for, the errors that is. Passing 512, that's the size of the array, null, and then info log, this is what we're going to assign any logs to. And for this, we're going to change this to shader program linking underscore failed. So now that we've checked for any errors when linking our shader program, we can actually delete the vertex and fragment shader because we're no longer using them. They're part of our shader program. We just need to just clean that up. So GL delete shader, and that is vertex shader. GL delete shader, fragment shader. Next, what we're going to be doing is creating the vertex data so we can actually draw it in terms of like the positioning. So we're going to put GL float is going to be a float array. I'm going to call it vertices square brackets equals to put a semicolon. So the left point, the bottom left point, is going to be negative 0.5f, negative 0.5f, 0.0f. So this is x, y, and z. We're not dealing with the z value in this video. We'll be dealing with that in a separate video, and we'll be looking at different ways of projection. So that's going to be very, very cool. Comma. So this is the bottom left. This is the bottom right, so 0.5f, negative 0.5f. F is the same y value because it's on same y point. Then put 0.0f, and finally the top middle point of the triangle, 0.0f, 0.5f, 0.0f. If you wanted a quad, you would have put 4 points, and you would just assign, or when you draw it, you would draw a quad instead of a triangle. That'll come with time, with a bit of practice. So these values might look almost a bit arbitrary. A little info. OpenGL by default, if you don't explicitly set it, it like the values of your screen range between -1 and 1. So 0 is in the middle, 0.5 is 25% of the way along from the middle, or 75% of the way along from the left hand side. In a later video, we will look at changing that system so it's actually using more, how should I put it, screen-like coordinates. So if we're doing 800 by 600, if we were to set, we could set a value of 567 by 200, for example. But that'll be in a separate video. So now we've got the vertex array created. What we need to do is create the vertex buffer object and the vertex array object. For that, we're just going to put GLU int call it VBO, VAO, semicolon, and we're going to generate the vertex arrays. So we can put GL, gen, vertex arrays, and in here just passing the value 1, passing a reference to VAO, vertex array object. Now we're going to generate the buffers, so GL, gen, buffers, 1, ampersand VBO. Now we're going to be binding the vertex array object first, then binding and setting the vertex buffers. So let's get on with that. We're going to put GL bind vertex array. We're going to put VAO. We're going to do GL bind buffer. So scroll up. GL bind buffer. GL underscore array underscore buffer VBO. GL buffer data. GL underscore array buffer. And we're going to be checking the size of our vertices. So this is a dynamic way of doing it without explicitly putting in the size. I'm going to pass in the vertices that we are drawing. And we're going to do GL underscore static draw underscore draw. So this is just the buffer data that we'll be using to be drawing our good stuff. And now we're going to be creating the vertex pointer. So we put GL vertex attribute pointer like so. So this has 0, so this is where it started in terms of what point. So this is the first point where it has 3 sets of vertices. What are the values, or what data type is GL underscore float. Put GL underscore false for this. Next we're going to do 3 times size of GL float, comma, GL void. Some of this might seem a bit heavy, just take it for granted for now, and like I said, we'll be explaining more and more as the videos go on and as you become more comfortable with it. And check out the open.gl and learnopengl.com websites, because like I said, they go into it in more depth in written form. So we've done the vertex pointer. We're going to be enabling the vertex array, so GL enable vertex attribute array. For this, just put a value of 0. So this is, we're just doing it at 0.0. Now we're going to be binding the buffer. So GL underscore bind underscore buffer. Oh, it's not underscore, it's just GL bind buffer. And this is going to take 2 values. One is GL underscore array underscore buffer, comma 0. And the next one is GL bind vertex array. And this is going to be 0. So this is unbinding the vertex array object. It's always a good thing to, well, unbind any buffer or arrays to prevent strange bugs. So yeah. The next thing we're going to be doing is actually drawing it now, finally, within our game loop. So where you want to draw it between the GL clear, so once the screen been cleared and before the screen buffers have been swapped. So first of all, you want to do GL use program. So this will indicate what shader program we're using, and it is shader program, the one we linked our vertex and fragment shaders to. Then you do GL bind vertex array, and we're binding the vertex array object. Now you want to do GL draw arrays, and this finally draws the bad boys. The first thing is the mode. This is GL underscore triangles. There's GL underscore quad. There's GL underscore line. Depending on how many vertices you have and what sort of object, your shape you're trying to achieve, this will vary, and we'll be covering more later on in this series. So now we're setting what is the first vertex, because maybe for whatever reason your array has 4 vertices and the first vertex is something else. You might want to start at the second index, which is index 1, the second row, second vertex. So you would put 1, but the first one for us is 0. Then we put how many vertices there are, so 3, semicolon, and finally put GL bind vertex array to 0. So we are just binding it, and now there's literally one last thing, and it's just some cleaning up. We're just going to be deallocating all the resources once they basically outlive their use. So outside of the loop, put GL delete vertex arrays. Assign the value of 1 because, well, this is where, let's go up here, this is where we put them 1, 1. Use the first one, so we're going to put ampersand VAO. And the last one is deleting the buffers, semicolon 1, comma, ampersand VBO. And yeah, we are ready to run now. So I'm just going to zoom out and run this bad boy. See what errors we get. 0 errors, which is good. And yes, our application has loaded with our triangle. Doesn't look very exciting at the moment. I know, it's just a simple orange triangle. And like I was saying, we'll scroll up and go to, yeah, this is where we would change the color. So let's say if we had 0 red and rerun that. Now we have a green light color because that is the most powerful variant here, because we got red, green, blue. If we were to, let's say, put 9 here, where blue is the most powerful, what is green and blue? I think we'll get some sort of purpley color for that. Oh, we got blue. Let's see what happens if we put 0.5. I'll recommend that you just experiment with it, see what you can get. Sort of like turquoise. Doesn't look very good. I'm just going to change it back to the orange because it looks pretty good on the background. So yeah, that has it. That's been it for a very, I want to say simple, because there's quite a lot to take in. So if you have any questions whatsoever, feel free to post them on our education platform, sonarlearning.co.uk. Again, check out the links in the description for OpenGL.com and Open.gl, which these videos are based upon. And you'll get more information because it's in written form, so they do explain quite a bit. So this video and their resources is a great set of resources for learning OpenGL. In the next video, we're going to be looking at actually taking out of this shader, putting it into separate files, and having a shader class that will handle all of the creation, because otherwise we don't want to clutter our application with this, and we want something that is reusable as well. So that has been it for drawing a triangle. Check out Sonar Learning if you have any questions. If you like the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. If you didn't like the video, leave us a comment as well. There will be a link in the description to the source code from this video and the source code from every other video in this series. And as usual, thank you for watching, and I hope you have a wonderful day.